So what you can get from this plot is that also you can discuss about the stability. So in the beginning of the lecture, maybe I talked about this. If there's a system, controller plant to plus minus, if there's a jiggling in and then there's a jiggling out, and if this in and out has total opposite sign, then because this is negative, this cyan, this blue part becomes, looks like this. And then if you add this part and this part together, it explode as time goes. So this, the phase difference between this blue, green and then blue, this light blue is 180 degrees. So that's the beginning of the stability of the body plot. So we don't want to go to the 180 degree in any case. And then gain margin or phase margin is the how much room you have to before you reach 180 degrees, which is very important because then the system will explode. And also the magnitude is the same between two plots, means that there's the input and output magnitude is the same, means that the gain, it is a 0 decibel, right? 20 log 1 is 0. So gain margin, the phase margin is discussed when this gain, the gain reaches 0, you just have a line and see if there's a room until it reaches 180 degrees. That is the phase margin. And then gain margin is that how much gain you have before this point goes to reaches the 0 decibel when the frequency is, when the phase difference is 180 degrees. So it's also it's the same as almost the phase margin idea. It's just make sure that it doesn't reach this 100 degree at 0 decibel. And how much room do you have like before it reaches 108 degree by looking at this magnitude plot. So the phase margin is the phase difference when the magnitude is 0, phase difference between the 180 degree and the current, the degree from the body plot, when the magnitude is 0, and then gain margin is that it is the how much gain you can have before it reaches 180 degree again. So this can be used a lot for actual experimental examples. So for example, for this case, so this is the plot you already saw again. 0 decibel means that you have the input and output is the same. And there's 180 degree here. And then there is also like this line. So seems like it was not very defined, but it has actually, it's very small, 45 phase margin at 20 Hertz. And the negative 3 decibel, where this is not related to the actual stability, this is typically express how fast the transient response, how fast the system can respond. So it means that until this frequency, the system output is almost the same as input. And after this frequency, even though the input looks like this, then output it looks like this. So it can't respond to the phase system. So for this, if you have more questions, you can contact me again on the time. But a more important one is the gain margin and phase margin. And then typically the phase margin is more often discussed because it really shows that how much room you have to make the system stable. So there are lots of phase delay sources, such as delay or friction. So you want to have like 30 degrees of the phase margin to make the system stable. I read that. This is the end of the lecture, and thank you for everybody and being patient and understanding these online lectures and give the feedback.